Dear colleagues, it's a great pleasure to talk in this Allergy Week of Apaaaci, which is aiming to increase the awareness and knowledge on climate change and major issues that the humanity is being exposed. I'll give two talks here. The first talk will be the pandemic of type 2 diseases and mechanisms. The first talk will be epithelial barrier hypothesis and the pandemic of type 2 diseases. I'll mainly focus here on the mechanisms. I would like to thank Professor Ruby Pavankar, the president of Apaaaci, for this organization. And I'll start my talk now. And this hypothesis is something very old, but also something very new as the data is collected together. The world is changing very rapidly. It is so much populated, quite overpopulated, and there is major threats to humanity and nature of the world. We will not discuss global warming and climate change today, but as you all know, that's a big threat. Exposure to toxic substances and development of 2 billion patients, which is going to be today's talk, epithelial barrier hypothesis. Pandemics of infectious diseases like COVID-19, Ebola, and also the red part will be the parts of this talk, staph aureus and antibiotic resistance. Biodiversity loss in the nature. We will talk about biodiversity loss in the microbiome and reasons of this biodiversity loss in the human microbiome. Ignorance of the above problems. Anti-vaccine groups, anti-science groups are also major threats to humanity. And as immunologists, we have to really handle this perfectly. We shouldn't give them any chance. And ignorant global leaders is also a big problem. You all know from your own countries. This can be a leader from the religious areas. It can be a leader from political areas, from political parties. So this is also a huge problem. I will start with allergic diseases. Allergen-specific and general type 2 response is a hallmark of allergic diseases. And it goes together with peripheral and tissue eosinophilia, epithelial barrier defect, goblet cell hyperplasia, excess and bad quality mucus production, mucociliary dysfunction, and remodeling. To better understand allergic diseases, we have to look at origins of type 2 response, which is expulsion of parasites and larvae. We go back around 90 years to Zurich University parasitology department and look at the studies of William Loeffler. William Loeffler at that time described the Loeffler's pneumonia in response to Ascaris, schistosoma, and hookworms. And if you follow the numbers, you will understand what's going on in Loeffler's pneumonia. And eosinophilic pneumonia occurs in response to Ascaris, schistosoma, and hookworms. And at that time, these small larvae, which are at the size of 0.5 to 1 millimeter, should be expulsed from the lungs because they will get adults at the size of 15 to 20 centimeters. And the coughed up larvae are swallowed, and worms get adult at the size of 10, 15 centimeters. So this is an important point here, that the epithelial barrier in the lungs opens, and all of the larvae are moved up and exposed to the mucosal lumen. And if it didn't work, this would be the case that we would see, and there will be a lot of ascaris coming from the bronchial tree, which is a deadly situation. So this is evolutionary guaranteed somehow that we show a strong type 2 response and eosinophilic pneumonia and eosinophilic inflammation to parasite. And here we have another example. This is Sarcoptes scabies, the agent of scabies. And we can see that this agent of scabies is also causing an eosinophilic dermatitis in the skin, and the skin also is trying to expulse this parasite in the best way. So what happened after 1960s is an important point. We had epithelial barrier damaging substances and exposure, and in 1819, the first cases of hay fever were reported by John Bostock, and in 1873, the first series was published by Charles Blakely. And it was very difficult to collect these series at that time. Nowadays, in an outpatient clinic, you can find these cases within 20, 30 minutes, more than hundreds of cases with one advertisement.
And in 1900, Swiss Army had only 1% allergic individuals. In 1960, there was also 1 to 3% allergic individuals. But the numbers after 1960 started to show a very significant increase. Swedish Army had 4.4% in 1971, which increased to 8.4% in 1981. And currently, Swiss Army has around 20%, and Swiss population has 28% allergic individuals. And in medal studies, there is 55% allergen sensitization. That means IgE to any allergic agents in the normal population. And after 2000, we had another series of events. Food allergy, EOE, drug hypersensitivity started to increase very significantly. So 1960 is the time that allergy and asthma pandemic begins. And it was noticed that the prevalence of asthma increased in Finnish soldiers very significantly in 1961. In early 1960s, it was noticed that asthma suddenly increased in almost every age group in England. From 1965 to 1980, there was a tenfold increase in the number of hospitalized children with asthma in Australia, England, New Zealand, Canada, and United States. Between 1971 and 81, it was found that asthma doubled to threefold in Swedish soldiers, especially those who came from the cities. And East and West Germany studies, you may be aware of, at the time when East and West Germany were united, the prevalence of asthma and atopic dermatitis were around 1 to 3% in East Germany, which caught up with the West within 10 years. That means a 5 to 10 times increase within 10 years. And in 1970s, which is the basis of ignorance hypothesis of Wolf-Zinkernagle, there was almost no IgE and IgG response to allergens. Healthy people had very little or no IgG antibodies to harmless environmental antigens in 1970s and 80s. IgE and IgG against environmental factors started to increase after 1970s, and specific IgE measured in frozen sera increased more than twice between 1990 and 1998 when measured even with the same method. But when we look at 2015's and these days, in 2015, 49.8% of Norwegian children aged 10 to 16 years had IgE to at least one allergen. In 2017, almost all adults were positive for IgG against olive, birch, and house dust mite. In 2018, IgG against milk and eggs was close to 100% in 1-year-old babies. This is amazing. You can imagine that about 40, 50 years ago, there was no IgG against eggs in babies, and nowadays it is almost 100%. And this is an important point for immunologists, and many immunologists don't know this. In a large panel test measuring 64 airway allergens in 2019, 90% of those with rhinitis, conjunctivitis, and asthma have at least one specific IgE positive. And this is a figure from 1960s, 52 to 66, and showing deaths from asthma. And deaths from asthma did not change between 1952 and 1960, but after 1960, children aged 10 to 14 years have tripled in 6 years, and again, children ages of 15 to 34 years have doubled. These are very major changes that deaths from asthma showed a very significant increase after 1960s. Another important pandemic, which many people are not aware, except the people who are focused on this agent, Staph aureus pandemic, started after 1980s. Staph aureus specific IgE was negative if only skin colonization was present in 1985. And when we were in medical school, it was very commonly known, and it was an exam question. There was usually 4% nasal carriers of Staph aureus. In 1985, only 12% of the pustulas, boils infected with Staph aureus had IgE antibodies. But when we come to 2019, Staph aureus specific IgE was positive in 39% of healthy people, 58% of mild asthmatics, and 76% of severe asthmatics. In 2020s, more than 95% of atopic dermatitis and chronic sinusitis have colonization of Staph aureus in the lesions. So this is a big change, and this only happened within the last few years, and this is a very major change that affected our lives, and that will certainly affect our lives, because staphylococcus is one of the major agents of hospital infections, and it is affecting all the mucosal inflammations. In addition, it's also affecting all the joint and bone infections, and it's a very major cause of these infections. What happened is something like this avalanche that happened in Davos about 2 years ago, and it was videoed at that time. A small avalanche started from the top of the mountains, and it really went down, affecting the whole area, and it became a very big avalanche, and it even turned the car upside down, which was making the video. So this is happening after 1960s, and we have to understand what are the reasons for this. And when we look at the reasons, humans started to be exposed to these agents in a very significant way. We were being exposed to cigarette smoke, bacteria, allergens, fungi, viruses, and in small quantities, house dust mite. But these other exhaust started at that time. And then laundry and dishwasher detergents started to be used very commonly in life, which really started in exactly in 1960 by adding surfactants to laundry and laundry detergents. And ozone increased. Nanoparticles came to our lives, and which is very interesting, that enzymes and emulsifiers in processed food increased. Microplastic is still increasing. Particulate matter is part of our lives. Household cleaners are using almost the same material as laundry and dishwasher detergents. And toothpaste, gluten sensitivity are together with this. And these factors are allowed by the regulatory authorities as a single factor, but nobody is considering that they are being exposed in an asthmatic lung, in a colitis gut, or in an inflammatory environment, and they have a synergistic effect between each other and between the inflammation. And leaky barriers allow the passage of allergens, pollutants, toxins, and microbes. So the microbes go between the epithelial cells, and they pass the epithelial barrier, and they make a micro-inflammatory focus right below the epithelium. And this is very visible when you look at the gut and when you look at the sinus mucosa. And in the lungs, we can see evidence for this. We don't see too much bacteria, but in the sinus of the asthmatic patients, we see a lot of bacteria passing below the epithelial layers. So if you look at epithelial barrier functions, we can see that there's a closed epithelial barrier is protective against environment and microbiome, and it is important to avoid loss of tissue fluids. And open epithelial barrier is also important, because if there's too much inflammation, just let's think about bronchoalveolar lavages or sputum, the open barrier is important to drain subepithelial inflammation. Cells, cytokines, and small molecules are drained to the lumen, but at the same time, allergens, pollutants, and toxins are going to deeper tissues. And we have looked at the effect of many agents, and this is a study by detergents, and detergents are diluted 1 to 50,000 times. Normally, a laundry machine has a dilution factor of 2,500 times, but we have shown here that at the molecular level, 1 to 50,000 times diluted detergent peaks, and this is true for many detergents. And there's a big change in RNA sequencing transcriptome, and we can find upregulated lipid metabolism, oxidative stress, and cell survival. At the same time, downregulated cell adhesion, extracellular matrix organization, and wound healing are taking place. So the interpretation of this finding is that if there is a detergent exposure, just think of an asthmatic child who just puts his head or her head in a pillow with detergents, and this 1 to 50,000 diluted detergents, when the child inhales, makes a chronic wound that tries to survive the cells. So the bronchial cells respond in this way, which is true also for the atopic dermatitis baby, which is a very common disease, infantile eczema, and about 10% of the babies in Europe are affected. And this baby is sleeping over the blanket, and there is still active dose of detergents, and this chronic wound in the skin tries to survive the skin cells. What happened after 2000s is also important. We have exposure to dishwasher detergents, dishwashers, and professional dishwashers came into life, and food emulsifiers. They were very little used actually before 2000, but nowadays in packaged food, they are in very high doses and in very high numbers of food contain food emulsifiers. Microplastic exposure increased significantly, and nanoparticles are everywhere. They are in the stains, in the material of our clothes, in the everywhere in the dishes, and also in the stains of the porcelain. Even there is nanoparticles. So food emulsifiers is a big change in our lives, and there's an important amount of data developing because food emulsifiers are surfactants. So if you want to understand the emulsifiers, just make tomato juice yourself, and in 1 hour, the liquid part, the water, separates from the body of the tomato. But if you put 1 teaspoon of a certain emulsifier, which is an allowed one, and you can use these emulsifiers like polysorbates, and you can make only 1% emulsion with this polysorbate, then you can see that tomato juice never separates the water and the solid part. And the emulsifiers are allowed now for ice cream, for pastry, for many juices, many soups, which is awful because they are damaging the gastrointestinal epithelial barrier very significantly. And here we have polyethylene sorbitan monolaurate, polysorbate 20, and polysorbate 80. Polysorbate 80 and polysorbate 20 are twins actually that you are using in the lab for your gels. And 1% of these are allowed in ice creams and pastry in Europe. And these are E432, E433. And there is a big list of emulsifiers that are allowed in food industry, and Ismail and Yağız are working on these in the lab. Micro and nanoplastic had a big change and our exposure. And it was thought that in maybe a few years ago, it was the problem of the Pacific Ocean, and then the marine species are being exposed. But currently, there's 100 million tons per year of microplastic is produced, and it is ingested by the cells. Microplastic is immune modulatory, epithelial barrier opening, and even nanoplastic or angstrom-sized plastic is binding to receptors. So this is a serious danger for now human life and life of inner cities, because in the normal asphalt from the tires of the cars, a huge amount of microplastic is being produced. And in all the packages, in polystyrene, polypropylene, the material that we are using has a lot of microplastic.
Now I'll stop this first part. I would like to thank our co-workers, Paulina, Ming, Mikhail, Kazu, Teru, Hide, Can, who worked on this project. And currently we have Zeynep, Ismail, Yağız, Ozan, Duygu are working on the project. I would like to invite all of you to our Congress, which is World Immune Regulation meeting, which will take place on the 6th of July in Davos. And this is our current institute. You are, of course, very invited to come and join us for research and education.